On your last mission, you were given two exercises. The answer for them is this. Advance further in your mathematical journey, and we'll meet again soon.
Greetings, esteemed adventurer, and welcome to your next mission on your quest on understanding complex numbers. Our quest today will be to find distances and midpoints of complex numbers. With that said, let's begin. What does it mean to find the midpoint of a complex number? Well, using a complex plane, we can represent complex numbers using points on the plane. The length between two complex numbers is the distance. But how do we find that distance? We can find the distance using Pythagoras' theorem. The base length is the length from the first point to the second point. This can be found through the difference between their real parts. And the height is the length from the first point to the second point. And this can be found through the difference between the imaginary part. After we find the base and the height, we can apply the Pythagoras theorem and find the distance, which is square root of base length squared plus height squared. Let's see an example. Let's say we want to find the distance between the complex number -8 minus 7i and 4 minus 3i. Then the distance will be square root of 12 squared plus 4 squared, which is equal to square root of 160. Oh, how about midpoints? The midpoint is the point at the center of the distance. To calculate the midpoint, we find the center of the base length and center of the height, and then locate their point of intersection. For example, if we want to find the midpoint of the complex number points 7 plus 8i and 8 minus 7i, then the midpoint will be 7.5 plus 0.5, because its length will be 1 and height 15. Then the midpoint will be 1/2 and 7.5 away from their initial point, and we can locate the midpoint by the two lines intersecting each other. I wish you well on your journey, dear adventurer. Here is your next task to continue further on your adventure, and we'll soon meet again.